prove these two triangles to be similar. Right, so I've got ABC and DEF. Right, and again, our three postulates that we can use here are angle, angle, side, 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 and side, angle, side. Right, so we first want to identify the postulate that we could potentially use here to prove these two to be similar. Right, looking at the diagram, I only have information given to me about the sides of the triangles. So I know that my best bet here is going to be using side, 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 right? I have the side lengths given in both triangles for all three sides. So I want to go ahead and try to set up my proportions and show that these side lengths are proportional to show that these two triangles are similar. So we're going to do short over short, medium length over medium length, and long over long here. So I'm going to start with my triangle ABC and find my shortest side, my medium side, and my long side. Right? And it's important to remember here that we're just going off of the numbers that are given to us and not just what looks to be the longest side and what looks like is the shortest side here. Right? Sometimes these triangles are flipped or rotated, and they don't always quite match up to what looks like the diagram is going to match up with those corresponding sides. So it's important that we go off of the numbers and the lengths that are given to us to set up these proportions. And then in my second triangle, we're going to do the same thing. So 22 is the smallest number. That's going to be my shortest side. My medium side is 25, and my longest side is 30. The easiest way that I have found to set this up to where you're not having as much error as you would is by setting up your fraction bars and then taking all of the numbers from the first triangle and putting them in your numerator, and all of the values from your second triangle and putting them in the denominator. Right. So I want to go small, medium, and large across. So I can go ahead and take my first triangle, which is ABC, and I'm going to order them in small, medium, and large here, or short, medium, and long. Then I can do the same thing with my other triangle, so I'm only looking at DEF right now, and I'm going to put the shortest side to the longest side in that same order. So we'll go 22, 25, and 30. Now that I've got these set up, I want to go ahead and try to reduce my fractions as best I can. Okay. My first one, I've got 9 over 22. So I want to find a number that I can divide both 9 and 22 by that's bigger than 1. Right. I know 2 wouldn't work here because 2 doesn't divide 9 evenly. And I also know 3 would not work here because 3 doesn't divide 22 evenly. Right. I could keep going up in numbers. I could try 5, I could try 7, I could try 9 itself. But if you were to work out that fraction, we know that this one can't be reduced any more than 9 over 2. Okay. So we're going to leave 9 over 22 as it is, and we'll move on to 10 over 25. Right. I can reduce 10 over 25 by dividing top and bottom by 5. Right. That's going to give me 2 over 5. And then we can also look at 12 over 30 and reducing that by dividing top and bottom by 6. Right? That would also give us 2 over 5 here. Right? I've got my 3 fractions here, right? 2 of them I were able to reduce to the same number, but since that first fraction wasn't reducible, right, and it's going to stay as 9 over 22, we know that these sides are not all the way proportional, right? So in this example, even though we checked with side, 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 since our sides are not proportional, we would get that these 2 triangles are not similar. Right? Since we know that they're not similar, we cannot complete that similarity statement. Right? So if you have a problem where it says finish off the similarity statement, you can just leave it blank and move on to your next problem.